Welcome to SS2 Chemistry, Term 3, Week 7. Carboxylic acids are ubiquitous. Ethanoic acid is the active ingredient in vinegar, citric acid is in oranges and lemons, fatty acids are components of fats and oils. Their derivatives, esters, give fruits their distinctive aromas. By the end of this lesson, you will name and describe carboxylic acids, explain their acidic properties, write equations for their reactions, explain esterification and hydrolysis, and answer WAEC examination questions. Let us begin. Carboxylic acids contain the carboxyfunctional group, COOH, which can also be written as C equals OH. The carboxyl group consists of a carbonyl group, C equals O, and a hydroxyl group, OH, on the same carbon. General formula for simple aliphatic carboxylic acids, CnH2n plus 1 COOH or CnH2nO2. IUPAC naming, select the longest chain including the COOH carbon, replace E of alkane with OIC acid. COOH carbon is always carbon 1, so no number is needed for position. Common carboxylic acids, methanoic acid, HCOOH also called formic acid, found in ant venom and stinging nettles, simplest carboxylic acid. Ethanoic acid, CH3COOH also called acetic acid, found in vinegar, 3 to 8% solution, most widely used carboxylic acid. Propanoic acid, CH3CH2COOH used in food preservatives. Butanoic acid, CH3CH2CH2COOH responsible for the smell of rancid butter. The name derives from Latin butyrum equals butter. Long-chain, fatty acids, hexadecanoic acid, palmitic acid, C16, octadecanoic acid, stearic acid, C18, saturated fatty acids present in animal fats. Octadec, 9, enoic acid, oleic acid, monounsaturated fatty acid, octadeca 9, 12 dianoic acid, linoleic acid, polyunsaturated. Physical properties. Carboxylic acids form strong hydrogen bonds, both between the COOH groups of different molecules, forming dimers, and with water. As a result, carboxylic acids have even higher boiling points than the equivalent alcohols. Short-chain acids are completely miscible with water. Longer chains become progressively less soluble. Smell. Short-chain acids have sharp, pungent odors, longer chains smell rancid. Acidity. Carboxylic acids are weak acids, they partially dissociate in water. CH3COOH plus H2O CH3CO- plus H3O plus ReQ. Ethanoic acid equals 1.7 times 10 to 5 mol/dm3 at 25 degrees Celsius, much smaller than Ca of strong acids like HCl, is almost equal to 10 to the power of 7. Compared to mineral acids, carboxylic acids produce a lower at the same concentration. Their solutions have higher pH than equimolar HCl or H2SO4. But carboxylic acids are still acidic enough to undergo typical acid reactions. Reaction with metals, 2CH3COOH plus Mg, CH3COO, 2Mg plus H2, magnesium ethanoate plus hydrogen. Reaction with carbonates, CH3COOH plus Na2CO3 2CH3COO plus H2O plus CO2, fission, CO2 evolved. Reaction with bases, neutralization CH3COOH plus NaOH CH3COONA plus H2O, sodium ethanoate, a salt. The anion CH3CO is the ethanoate ion, acetate ion. Salts of carboxylic acids are named with the IC acid ending changed to ate, methanoate, ethanoate, propanoate, butanoate. Esters contain the functional group CO, ester linkage. They are formed by the reversible reaction between a carboxylic acid and an alcohol, with a concentrated H2SO4 catalyst and gentle heating. This is esterification. General equation: carboxylic acid plus alcohol ester plus water. Example: CH3COOH plus C2H5OH CH3COO C2H5 plus H2O. The ester formed is ethyl ethanoate, ethyl acetate, the smell of pear drops. Since the reaction is reversible, the yield is limited, typically 65 to 70% at equilibrium. To drive the equilibrium forward, remove water as it forms, remove the ester as it forms, use excess of one reactant, usually the cheaper one. Naming esters, the first part of the name comes from the alcohol, change OL to YL, the second part from the acid, change IC acetate. Examples: ethyl ethanoate, from ethanol plus ethanoic acid; methyl propanoate, from methanol plus propanoic acid; propyl methanoate, from propan, 1-OL plus methanoic acid; pentyl ethanoate, smells of bananas. Hydrolysis of esters, the reverse reaction, ester plus water, acid plus alcohol. Acid hydrolysis, H2SO4 or HCl catalyst, warm reversible, forms the carboxylic acid and alcohol. Base hydrolysis, saponification, NaOH irreversible, forms the carboxylate salt, sodium salt, and alcohol. Saponification is the chemical process behind soap making. Fats, glycerol esters of fatty acids, plus NaOH glycerol plus sodium salt of fatty acids, soap. Soaps are sodium or potassium salt of long-chain carboxylic acids. Their long nonpolar alkyl chain is hydrophobic, dissolves in oil/grease. Their polar carboxylate head is hydrophilic, dissolves in water. This amphipathic structure allows soaps to emulsify grease and wash it away. WAEC questions on carboxylic acids and esters test: writing the IUPAC name of a carboxylic acid or ester from its structural formula, drawing the structural formula from the name, writing balanced equations for esterification, identifying the ester formed from given acid and alcohol, and naming it, explaining why carboxylic acids have higher boiling points than alcohols of similar mass, explaining soap action, the reaction of carboxylic acids with metals, carbonates, and alkalis, explaining why carboxylic acids are weak acids and what weak acid means. Common mistake: confusing the order in naming esters. The alkyl group, from alcohol, comes first, then the carboxylate, from acid. Worked naming example: what is the name of the ester formed from methanol and propanoic acid? The alkyl group from methanol equals methyl, the acid part equals propanoate. Answer: methyl propanoate. Another common mistake: thinking esterification and neutralization are the same. They are not. Neutralization, acid plus base, is fast and complete. Esterification, acid plus alcohol, is slow, reversible, and requires a catalyst. Both produce water as a product. Key points: carboxylic acids contain the COOH functional group, general formula CnH2nO2. Named using OIC acid suffix. Methanoic acid, HCOOH, ethanoic acid, CH3COOH, are the most important in WAEC. Properties: high boiling points, H bonding, soluble in water, short chain, weak acid, partially dissociates. Reactions of carboxylic acids, with metal salt plus H2, with carbonate salt plus H2O plus CO2, with bases salt plus H2O, with alcohols ester plus H2O, esterification, H2SO4 catalyst, reversible. Ester naming: alkyl group, alcohol, plus carboxylate, acid, example, ethyl ethanoate from ethanol plus ethanoic acid. Esters, sweet/fruity smell, used as flavorings and solvents. Hydrolysis, ester plus H2O, acid plus alcohol, acid catalyzed, reversible, or salt plus alcohol, base catalyzed, irreversible. Soap, sodium/potassium salt of fatty acids made by saponification. Soap action: hydrophobic tail dissolves in grease, hydrophilic head dissolves in water, emulsification.